In this video, we'll be looking at reflections in the coordinate plane, part of our transformational geometry conversation. We'll be working on pages 10 through 11 in the Algebra 1 summer math book. So a reflection is one of our types of transformational geometry. It's also an isometry. It's what we consider a flip over a line called the line of reflection. And the line of reflection is just whatever line you're reflecting over. Okay? Each point and its image are the same distance from the line of reflection. So the starting point, the pre-image, and its image are going to be the same distance from the line of reflection. And we can see that in our example here, where C is 1 point away from the y-axis, and C prime, the image, is 1 point away from the y-axis, where in that case, the y-axis is the line of reflection. Okay. A reflection is also an example of a rigid motion or an isometry, meaning that the shapes, the corresponding sides and angles are all congruent. Okay. Some common lines of reflections we're going to look at in our work is reflecting over the x-axis, the y-axis, and diagonal lines of y equals x and y equals negative x, which we should be familiar with from your work in 7th grade from linear equations, from graphing those lines going through the origin with a slope of 1 and negative 1. Some other common lines of reflection you can work with is really just any x equals a number equation, meaning a vertical line, or any y equals a number equation, a horizontal line. But we're not really going to look at that in this summer math work, but it's good to know that that happens also. And there you would just count spaces back and forth, similar to the x-axis and the y-axis. So first thing we're going to do here is take triangle ABC with the given vertices on our graph, and we're going to reflect it over the x-axis. To reflect over the x-axis, I'm going to start by just using that fact that each point and its image are the same distance from the line of reflection. So our x-axis right here is our line of reflection. So I'm just going to count spaces. C is 1 space above, so C prime is going to be 1 space below. B is 1, 2, 3, 4, 5, 6, 7. So it's going to be 7 below. 1, 2, 3, 4, 5, 6, 7. And that'll be B prime. Okay. A is 2 above. A prime will be 2 below. There we go. We'll make our triangle. Hope you're using a straight edge. So yours looks better than mine. Okay. And then we're just going to jot down our coordinates of A prime, B prime, and C prime. Okay. I can see that A prime is -4, -2. B prime is 4, -7. And C prime is 5, -1. Now, what do you notice? What do you notice as we reflect over the x-axis? What happens to the coordinates of A, B, and C as they become A prime, B prime, and C prime? What I notice is nothing changes with the x-coordinates, but the y-coordinates change. Their sign changes. They become negated. So our rule for reflecting over the x-axis, which in our transformation notation we showed just like this, we're going to reflect over the x-axis. That's how a problem could ask you to reflect over the x-axis. And we're going to show our rule using coordinate notation that xy goes to x negative y, where the negative y just means that sign's getting negated. So if it starts positive, it becomes negative. If it starts negative, it becomes positive. Okay, so let's try one now, reflecting the rhombus WXYZ over the y-axis. So now our y-axis right up here is going to be our line of reflection. Again, I'm just going to count spaces. This one's a little more difficult because our rhombus is already straddling the y-axis. Okay. So if I see W is 2 spaces to the left of the y-axis, so W prime will be 2 spaces to the right. X is 1 space to the right. X prime will be 1 space to the left. Y is 1, 2, 3, 4 spaces to the right, so Y prime will be 1, 2, 3, 4 spaces to the left. Z is one space to the right. Z prime will be one space to the left. It's a little hard to see with how small it is, but we can see it's just flipped over that y-axis. So let's jot down the image points. And again, we want to notice what happens with our coordinates as we reflect over the y-axis. I can see nothing changes in our y-coordinates. The x-coordinates change. They are negated. What starts positive becomes negative. What's negative becomes positive. So writing our rule, a reflection over the y-axis, we'd write as xy goes to negative xy, showing that the y is going to stay the same, but the x coordinate is going to be negated. Okay, so here, this one, a little different, a little tougher, because now we're reflecting over the line y equals x. We want to remember our line y equals x, right? Y equals mx plus b, that this line is going to go through the origin, and it has a slope of 1. So I'd start at the origin, and then a slope of 1 tells me go up 1 to the right 1. Just like that. When I run out of space, I do the opposite, down 1 to the left 1. And I'm going to make that a dotted line because that's what we're reflecting over, but it's not really there. And always a good idea to label it. Okay. Now, as we reflect over the line y equals x, it can be a little bit more difficult to count the spaces. So our rule for reflecting over the line y equals x is given to us in the line itself, that your y is going to equal your x and your x is going to equal your y. So that's just going to say if we reflect over y equals x, that xy is going to go to yx. We follow our rule and we take x, -5, -2. That's going to be -2, -5. So we'll plot that right there. There's our x prime. Y prime, take y, -3, 4. So y prime is going to be 4, -3. They're just swapping places. So 4, -3. There's our y prime, and z, -1, 1 will become 1, -1. So that'll go right there for z prime, right? And we'll connect our lines, right? We see a nice congruent triangle. You can see how it's equidistant from that line y equals x. You can see equal diagonal spaces between them. Okay, so we're going to do something very similar with triangle STU in the next graph, but this time we're going to graph the line y equals -x. So now this is going to have a slope of -1. So it's going to go through the origin, but this time instead of going up 1 to the right 1, it's going to go down 1 to the right 1. Run out of room, go up 1 to the left 1. And again, we're going to make a dotted line. And I want to label it somewhere. Okay. And I'll use the rule again here. And this rule is a little trickier because it tells me whatever my y value is going to be the negative of the x. Okay. So for example, s is -1, -6. So the y value is going to be the x times -1. So the x is -1 times -1 will give us a +1. Just like that. And we'll come back and we'll talk about the x's in a moment. Okay. So our y, t, 0, -3. The y is going to be the x times -1. 0 times -1 is just 0. And then u, 3, -4. So our 3 times -1 will be -3. So we figured out our y coordinates. Figuring out the x coordinates is a little more complicated, but we still get it from our rule. So if I want to know what the x is, I'm going to solve for the x, get it by itself. So I do that dividing by -1, which means x is going to be equal to the negative of the y. So our rule, reflection over the line, y equals -x, is xy goes to negative y, negative x. That's our rule. And that's one of those you kind of just have to memorize to use it. Okay? So using that, our x coordinate in each of these is going to become the y times negative 1. So s prime negative 6 times negative 1 is going to be a positive 6. T prime negative 3 times negative 1, positive 3. And u prime negative 4 times negative 1, positive 4. And then let's plot it. S prime is going to be 6, 1. T prime 3, 0. And u prime 4, negative 3. Okay. We can see congruent triangle, equidistant from the line of reflection. As you go and do your work and you're reflecting, I would use the rules, right? So sometimes we're not given a coordinate plane, or we are, and we have to figure out the points, right? For me, this is where I would be going back to my work, and I'm really going to be just focusing on flipping back to the page and just using these rules we have. Okay, so if it's reflecting over the x-axis, I'm going to look at that rule. Y-axis, I'm going to look at that rule. Y equals x there. Y equals negative x there. So definitely use these rules to your advantage.